So today we're going to talk about the skills that you're going to be needing for lab number 3. Remember, lab number 2 has to be demonstrated by the end of Susanna's office hours on Thursday. Hopefully everybody, is that correct? Yes? Does anybody have any additional hints they need? Or do I cover this at all? Okay, everybody's quiet. So, breadboard, this slide and the following one pretty much sum it all up in that the only thing that might be different on some of your breadboards is, this is the small one. There is a longer one. I've seen a couple of you have that. Does anybody have theirs with them? A longer one? Is that a yes or a no? Yeah, do you trust throwing it to me? And this is a good example. Does anybody else have another one? This is one thing I want to show on this. So on the longer one, notice this. In the middle, these lines just keep on going all the way. The blue and the red ones. Does anybody have a longer one that has a break in there somewhere? Yes? No? Does it have a break in the middle?
Yes.
Okay. Can you run that down to me? I'm not going to have you throw it because, I don't know. I think I was really lucky to catch that one. Say it again?
I didn't hesitate.
Yeah, I know you didn't, but I am, so. Okay, this is great. Here's hoping I get to the right one back. All right, remember, one of these things is not like the other. Do you notice a difference? Kind of. Oh, man. Yeah, I still get too much reflection. Well, you can pretty much tell right there, right? You see the break? See there's no break there? What it means is that in this board right here, that this wire or these pins along here, they actually are connected, but it's only from here to here, and the wires then are connected from here to here. But this row of pins right there, right next to the blue line, is not connected to these, as opposed to this other board over here where they go all the way through. You know what? This is, I'm going to open up your nice pristine board, sorry. Oh man, this thing is like insane. Oh, it's Radio Shack. So this is obvious that you can tell that it's broken in the middle. The nice reason for this is that these sets of pins can be totally separate from these over here, and you could have actually different voltages. And typically, you're going to rely on the blue to be ground, 0 volts, and then red. You could have, in this case, 2 different VCCs on that column right there. On this one, you're kind of stuck with them all together. And oh yeah, this has this. You got to buy the same. You got to buy the same kind, but you notice on one side it has these things that look like little notches, and then on the other side it looks like things that have little holes. And that allows you to put a whole bunch of these together. All right, now I got to figure out who's went where, and I'm gonna have to send these to I'm gonna have you put these back together because I'm just lazy. All right, so that is that. Let's go on. So everybody knows how, oh, by the way, which one of these 2 circuits up above is incorrectly attached? Well, oh, do I say? Yeah, which resistor is wrong? The top one over there? Because it's in the same column of pins. And that means that both ends of that resistor are electrically connected together. So the objective is you want to do something more that looks like this down below, that being how you're taking a wire from port 1.5, putting it into one of the rows, connecting a resistor, and then connecting a LED. One thing to notice there, so I'm lighting up one of the LEDs. How many actual wires am I using there from, just it has a wire that's either male at both ends or female at one end and male at the other? One, right? I'm using one wire. I'm using the resistor and the LED to kind of hook things up, right? And that's a way to limit the number of wires you actually use on a breadboard, to actually use the components to stick in them little holes rather than relying on additional wires. Because I could have put, an LED connected in one of those columns and then a wire from one of those columns to ground, and then a wire from here and there and everywhere else. But the fewer components and wires you have on the board, the better it makes it, because otherwise it's going to get really messy. All right, let's go on. So if you remember the objective for lab number 3, if you remember the code from number 2, and of course the comment line, we saw what that was. And just a refresher also on the switch. So in this case, here we have 2 switches, and they could be wired such that it reads a 0 when it's pressed, or it could be wired so it reads a 1 when it's pressed. There's actually 2 different ways. You're going to see 3. Why do we do 2 different ways? Well, one of the switches is wired on the board itself, on the MSP430 launchpad. And that's one way of doing it, which is actually a little bit harder. So we're going to see another way to do that. Oh, look at that up there. You have, in this case, if you are, these are the same ways, I'm sorry. So this is what we call a pull-down resistor. Remember, if we are not pressing the switch, it's going to read 0. And if you are pressing the switch, it's going to read 1. In this case, VCC is 3.3 volts. And if I were to read this, I would say P1 in. All right, so P1 in means go to port 1, input, read the input, and in this case, I'm storing it in a variable called data. And then later I can interrogate the data variable. So if it just so happens that the switch, which one? Switch number 2, let's say, is on port 1, bit 3, and I would read it. That means I would read 00001000. See that 1 bit there, that's bit 3. Remember, we count 0, 1, 2, 3 from the right. So that's just a refresher. Oh, and so that's the same as hex 08 and decimal 8. So if that's how we read it, P1 in, and this is going to be our circuit, notice the difference between between switch 2 and switch 3. By the way, switch 1 on our board is the reset switch. So if you press that, it actually reboots itself. So in this case, if I'm not pressing the switch number 2, what would I read on port 1.3? If I'm not pressing the switch number 2, I would read logical 1, correct? And if I am not pressing the switch on on port 1.4, which is switch 3, what logic value would I read if I'm not pressing the switch?
0.
0. Well, yeah, it's over on that side, right? But look at the drawing and understand that. Now the reason we have these, what we call a pull-up resistor and a pull-down resistor, is because we never want to have a situation where you're connecting power and ground directly to each other. So imagine this. If I had way up in that corner for switch number 2, if I just had a direct wire right here, so if I had a direct wire right here rather than that resistor, it would be fine when you're not pressing the switch. But as soon as you would press this switch right here, what would happen? You had VCC. Remember, there's no resistor here. It goes through the switch and it goes directly to the ground. And you know what that's called? A short. And you never want to short power to ground. And so you always have to have somewhere in there a resistor just to make sure that you're not directly shorting it. Question?
Why use a resistor instead of a diode?
Ah, good thing. Why a resistor and not a diode? What does a diode do?
Current go only one way.
In only one way. Is there any consumption of current in that diode? No. So what does that mean? You're still shorting power to ground. So diode is only good for restricting the flow of current in one direction. But you still have a flow of current from VCC down to ground.
That's what I was saying, is if you only go into VCC and not out.
Well, here's the other problem then. So what you're saying is if you put a diode up there so that current only goes from the microcontroller up to VCC, don't forget it's an input device, so it's not actually sourcing any voltage. In that case, it would be what's called a floating pin. And input devices, you never want floating. You always want it tied to 0 or tied to 1. Tied to 0 volts or tied to 3.3 volts. That's a good question. I like that. Did you ever get a trip to the prize closet yet? You can come up for a trip to the prize closet. Woo! I got a t-shirt. I also owe somebody else in here some. You got to come up after class. All right. So any other questions about this? So we're going to take a look at some of the uses of this, and so let's take a look. We're going to be looking at a new instruction to implement that pull-up resistor. Now, remember how I said it's how it's wired on in the launch pad? Well, that's inside the processor is actually where this pull-up resistor exists. And we're going to look at an example of using that P1 REN instruction. All right? So now that's what our port 1 looks like. Now technically, LED 1 is over there too. Which pin is that on? Or, yeah, which pin is it on? LED 1?
Bit 1.
Is it on bit 1 or bit 0? Oh man, you guys are just doing this for lab number 2. I believe it's bit number 0, right? And so now we're going to have LED 2 and LED 3 on some other ports, right? So let's take a look at this, and I think we looked at this as well. How would I, we just had a quiz on this, but apparently some people got nervous. So turn to your neighbor and answer this question. What instructions do you write to light no LEDs, LED 2 only, LED 3 only, and both LEDs? So go ahead and we'll pause the recording. All right, the quick answer for this, I think everybody got this, right? Yeah. First of all starts P1 out. And it's all hex. And the first one is 0, 0. Don't forget the semicolon. The next one is here 2, 0. And the last one is 6, 0. Correct. Woo woo. Is that still going? Good. So now let's take a look at switches and how we're going to use switches. So remember, switches are input. So to read these, we're going to have to say P1 in is equal to, or we're going to send our result into P1 in, or P1 in result into, in this case, a variable. We'll create what's called a character variable, which means it's only going to be 8 bits. And, oh, look at this. What is that and sign up there? So that is in C. Haven't you covered that in C yet? That and thing? Yeah, all right. That is a bitwise and. So remember 2 weeks ago I talked about logical ands and ors and stuff like that? So now we're going to be doing our logical ands. So let's say, and remember switch number 3, when it's not pressed, we're going to be reading 0. And when switch 3 is pressed, you're going to be reading 1. And, we're going to look at switch number 2 in this case. All right, let's look at switch number 2. So when switch number 2 is pressed, you read a 0. It's kind of opposite to what you would expect, right? But you just have to know how the hardware is set up. So just remember, when switch number 2 is not pressed, you're going to read a 1, a logical 1. So what does that mean? Well, the top row here identifies what you read in. So we really worry about switch number 2. And do you remember that drawing that I had a little while ago, which I think is a little bit shifted right here, so I'm going to have to fix that. Oh, there it is. Switch number 2 is bit 3. And here is bit 3 right here. Ah, close. And remember what I said is that, let's say, oh, by the way, by looking at this, and this side over there, I'm actually pressing switch number 3 at the same time too. So over on that side, I'm pressing switch 2 and switch 3 at the same time. And that's what I'll get on that top little line, 0, 0, 0, 1, 1, 0, 0, 0. But at this point, I only care about bit number, or the bit associated with switch 2, which is bit number 3, the one I have highlighted. So in this case, what I can do is I can AND what I read in with the bit pattern 0, 0, 0, 0, 1, 0, 0, 0. What you see in the second line there. And so when I do a bitwise AND on that side, it all turns out to be 0. On this side, I'm isolating the switch number 2 position, and then I read over here, and I'm going to be left with 0, 0, 0, 0, 1, 0, 0, 0. In other words, over here, I'm only looking at, after I've done the AND, I'm only interrogating switch number 2. Why is that important? Because I don't care about switch number 3. And if I don't do that AND, I'm going to get information there about switch 3 and switch number 2. But I only care about switch number 2. So by using that AND operation, I can just worry about switch number 2 in that case. This is probably the hardest concept to understand because, in this case, we're kind of switching 2 and 3 work. So it needs a little bit of re-emphasis, and I'll visit this again. Does everybody understand that? So, what I want you to do is what would you write to examine only switch 3? So I showed you up there what you would need to examine only switch number 2. What would it take, or what would you need to examine switch number 3? So let's take a quick break, turn to your neighbors, and figure that out. All right, so I'm going to pick on you. What is it?
It's char read it, and then read it equals P1N, and then read it equals read it and 0x10.
Very good. 10 is the one thing we're looking for. Now, here's a neat thing is that you could do a lot of stuff here. Oh, I should probably write this up here. Let's see, the important thing was, let me get the full line. Read it equals and hex 01, right? I'm sorry, 10. It's my dyslexia coming out. Now, really, this is C code, and we could just be really fast, right? Because we're going to compare things later, right? So one thing that we can do is we can actually say P1N and 0x10, and then we could start working on that, because we don't have to save it intermediately, right? We could just go into using it. And we're going to see that later, where you actually just read in the port, you identify the specific bit you want to look at, and then you go on. By the way, what would we write if we wanted to look at only switch 2 and switch 3 at the same time, and nothing else? Just switch 2 and switch 3. All right, 1/8. So if we wanted to look at switch 2 and 3 at the same time, we would write that as 1/8. And we're going to see that in our coming slides. So let's build this table for lighting LED number 2. And this should give you a good flavor of how you're going to use switches to help light LEDs. So switch number 2, remember it shows 0 if you press it. It shows 1 if you don't press it. So that means that if you read the switch 2 and you see it as pressed, then we want to output and keep it off. Because lab assignment number 3, we're making it such that when you press the switch, it turns the light off. When you take your finger off the switch, it turns it on. All right? Oh, that's really opposite, isn't it? But it's the way we designed the hardware. So would you agree? Well, that's like 2 lines of the same thing, right? The top 2 lines look the exact same as the bottom 2 lines, right? Why would I do that? Well, I'm going to take into account switch number 3 in a minute. So again, we're going to read switch number 2. So we're going to do the P1N and 8, because we're looking at switch number 2. And if we happen to read it and it's 0, that means I have pressed it. And so that means I output and I turn off LED number 2. You understand this. This is important to understand this slide. Everybody get this? Yes? No? Maybe? Which is it? All right, I tell you what. Let's look at switch number 3. So we're going to figure out for LED number 3. So when you, I haven't written anything up there, right? So when switch 3 is not pressed, I'm going to turn on the LED. When switch 3 is not pressed, I'm going to turn on the LED. When it's pressed, I turn it off, press, turn it off. So the table will change later when we accommodate for P1 rend. We're going to look at that later. So, oh yeah, this is an empty table right now. I want to see what P1 in and P1 out are going to look like to fill in this table. So right now, turn to your neighbor and figure out what those two columns, P1 in and P1 out, are, and then help me fill in what this is down there. When you're ready and I'm facing you. We're up and running, so let's take a look at what you think the answer should be. And I'm not sure if I actually wrote it in here. Well, yeah, I'll just do it in here. What the heck. So, yeah, it would have been, it's a little bit different. So this would have been 0 hex 20. And this would have been 0 hex 00. By the way, P1 in, as we're reading it in and looking at it, is we're only looking at this bit right here, right? In this case, it's 0. So the obvious answer for this is 0 hex 00. Because we're only worried about switch number 3. And so this is 0 hex 10. So that means that if read it is, and you're reading it is switch to press turn off LED, so that means if it's pressed, which means it's going to be 1 0, then we're going to turn it off, which is going to be 0 0. Otherwise, if read it is equal to 0 0, right, then we're going to turn it on. Easy enough, right? Easy peasy lemon squeezy. Now, let's put both switch 2 and switch 3 together, and we're left with this. So what we're left with is, we're building the table for lab number 3. The table will change for P1 Ren, which is the next slide, I believe. Now we're going to isolate 1 8. So the pattern 0 0 0 1 1 0 0 0. So we're going to isolate these two switches. If when we read those switches, it's 0 0, that means that switch 3 was not pressed and switch 2 was pressed. That's why I went through this table previously so you can get a flavor of this. So just building this table will keep it all straight for you, because later you're going to create this table, or you're going to create this code that will tell you how to solve lab number 3. So for example, in this case, if we read 0 0, 0 0, there it is right there. That means that switch 3 was pressed, switch 2 was not pressed, but more importantly, that means we need to turn off LED 2 and turn on LED 3, and that's the instruction that the data that we use. So we'll just identify that right there. Now on the next line, so we have to take into account all of the different situations, each one of these lines. So if my value I read is 0 8, looking at the table, there it is. Switch 3 is not pressed, switch 2 is not pressed, which means both of my LEDs should be on. Both of my LEDs on means 6, 0. Whoops. This should be 6, 0. So I got to fix that. There's going to be 3 more lines. An else if, a read it is equal to something else, and an else if, a read it is equal to something else. That's what you have to figure out for lab number 3. Now there is one last skill that you need to know, and that is, remember way over in this slide right here, I showed this saying part of the microcontroller pull-up resistor. Well, what we have to do is that we have to activate this pull-up resistor, because this you're actually putting on the breadboard, but this is inside the MSP430, the little processor that you see on your board. So to take care of that, we're going to have to add an extra thing in there. And the extra thing we add, let's see, here it is right here, is we actually have to say P1 ren, and then we have to write to the switch number 2 input. So even though switch number 2 is an input, we actually need to output to it every time we output. So in this case, notice here, in the previous slide, remember this is 20600040. Now it's 28680848. So you have to make sure that you do this P1 ren all the way at the beginning, and then you have to make sure that that's going to be 8. But all you need to do for lab number 3 is to use this table. So putting everything together, your P1 DIR, I'll let you figure that one out for the 2 LEDs. You have to set the P1 ren. Just for grins, you can turn on both of the LEDs and activate that pull-up resistor, and then you put your logic in here for working with the switches and all. Now, here is, this should be the last slide, but I did skip over one. So, remember we talked about isolating all of this with an and notice here, you know, we use this bitwise and right there. And we said, you know, you could equal. So as opposed to this instruction where we said we're going to do this bitwise and store it in a variable, you can actually just incorporate that inside of the instruction rather than putting it into a variable. So literally for lab number 3, this is the code that you put in your while loop. And while you can take a picture of it, you know, this is on the slides already on Moodle, so you could remember it, right? And then this is the other code. Don't forget about the include the main disable watchdog timer that you get when you start up your application. And that's lab number 3. Question? P1 direction. You have to identify the direction of the input and the output ports. Remember that from last week? No, you don't remember it from last week. Okay. So the refresher from lab 2 code is, since you had 2 output devices, you need to identify which 2 ports are output devices. And well, let's take a look from this, right? What are the 2 output devices? LED 2 and LED 3, right? So we have to make sure that when we say P1 DIR, we're going to have to identify that this is output and this is output. But we also have to identify that this is an input, use a 0 for input, and this is an input, use 0 for an input. The rest we'll just set as inputs. So that means we have the bit pattern 0, 1, 1, 0, and 0, 0, 0, 0. So what is this binary pattern? So the binary pattern is 6, 0, and hex. All right, answer your question? All right. Any other questions? Thank you very much.